Concentration is the quantitative description of the amount of solute in a solution. There are three main units of concentration that chemists use. We will discuss them in separate videos. The first one is molarity, and is the most common. Molarity is the number of moles of solute per liter of solution. That gives us the formula for molarity of moles of solute divided by liters of solution. You will learn this and become very familiar with this formula, but it's also in your reference packet. So let's look at the problem. Number 1. This is in your notes packet. What is the molarity of a solution made by dissolving 3 grams of sodium chloride in 1 liter? So according to the equation, we have to have moles of our solute. So our solute is sodium chloride, but we have grams. So we must first convert the grams to moles. So step 1 is convert our grams to moles. So if we have 3 grams sodium chloride, to convert that to moles, we want to get rid of grams, so they'll go on the bottom, and moles will go on top. We know that the molar mass is for 1 mole of any substance. So we calculate the mass from the periodic table. And so we have 1 sodium, which is 22.99, plus 1 chlorine at 35.45, and that gives us 58.55, 44. So since 58.44 is on the bottom, we're going to divide, and we get 0.051. I'm keeping 2 significant figures because that was what was given to me in my problem. Step 2 is to plug into the molarity formula. So molarity is equal to the number of moles divided by the number of liters in our solution, which we were told was 1.0. So we divide and we get 0.051. And we use a capital M to signify molarity. You can also use mole per liter. Both of those units are acceptable. Question 2. What mass of potassium nitrate is needed to make 2.5 liters of a 0.25 molar solution? First, in this case, since we know our molarity and we know our liters, what we want to find is mass. So we must first plug into our equation. So we have 0.25 equals the number of moles, which we do not know, so we'll put X, divided by our liters of solution, which is 2.5. So then we solve for our number of moles, which is X. To do that, we're going to cross multiply. And so we get 2.5 times 0.25 is 0.63 moles is equal to X. Again, I kept 2 significant figures because that's how many were given, each of those numbers in the problem. Our final step, because the problem asked us for mass, is convert moles to grams. So if we have 0.63 moles of potassium nitrate, to convert that to grams, my moles need to go on the bottom, my grams on the top. Remember, it's always 1 mole of molar mass. To determine the molar mass of potassium nitrate, we add up the masses of each of those. Potassium is 39.1, nitrogen is 14, and 3 oxygens are 48. And so that gives us 101.1. All of our numbers are on the top, so we're going to multiply. and we get 64 grams. Again, in the calculator it actually says 63.693, but we're only allowed to keep two significant figures because that's how many were given in the problem. And so that's 64 grams. Next, I would like for you to work on the practice problems in your packet. These are the answers, so you know that you got them correct. Don't forget that you need to round to the correct number of significant figures.